All right, so now we move on to lesson 3, which is slope formula. Slope formula, just like the previous lesson, is going to be broken into 2 parts. Well, first of all, we're going to introduce the slope formula, and then we're going to do some problem solving involving the slope formula. Okay, so let's begin. Lesson 3a, slope formula. Consider the line segment to the right here, and then let's determine the coordinates of A and the coordinates of B. Well, if I look at the coordinates of A, I have 3 for X, 2 for Y. So I'm going to put that in here, and we say we have 3X, 2Y. Then I go to the coordinates of B, and I say I'm all the way over here, which is 8 for X, 6 for Y. So 8 for X, 6 for Y. There we go. Now, recall that the slope of a line is the change in y over the change in x, or the rise in over the run. So what we're going to do is from A to B, or when we look at these from left to right, what is the change in y, or how much do we have to increase by? We would see that we would have to increase by 4 units, or 1, 2, 3, 4 to get up. So our change in y for this first piece is equal to 4 units upwards. Now the run is how much we go to the right, or 1, 2, 3, 4, 5. So our change in x is equal to 5 units, and therefore the slope, which is represented by m, we always say m is equal to the change in y over the change in x, therefore being change in y, which was 4, over the change in x, which is 5. So there's our slope of the line AB. Now, what if we rephrase it so that we're reframe it from the point of view where instead of going from A to B, now we're going from B to A? What does that mean? We're going to be looking at it in the reverse direction. If I go from B and now I want to go down to A here, what is the slope here? So what we'd have to look at is how many units is it changing in the vertical direction? We would see that it's going to be 1, 2, 3, 4, or negative 4 units down. And then it's going to be 1, 2, 3, 4, 5 units, and 5 units left means we're in the negative direction there. So now when I piece this together, what is the change in the y coordinate? Well, the change in the y, or the rise, is equal to negative 4. And then the run, which is the change in x, was equal to negative 5. So therefore the slope, being the change in y over the change in x, is equal to negative 4 over negative 5, which is equal to 4 over 5, because we know those negatives are going to cancel. Now, the one thing we should notice right away, the slope, whether we calculate it from A to B or B to A, it gives us the same thing. Reason being is that when we look back at this graph, it's not that the line is changing, it's just that the point of view and the direction we look at it is changing. But the slope of the line, or the line segment itself, will remain consistent. All right, so this is where we introduce slope formula. Slope formula always symbolizes, if we look at 2 points that are on any given line, then the slope between those 2 points will be represented by the following. M, which is our slope, is equal to y2 minus y1, or the change, if you want to fill this above your notes here, it's the change in y over x2 minus x1, which is the change in x. And similarly, our second fraction here, or this piece, is what if we just approach it from the opposite view? Instead of going from left to right, which is symbolized by this one, our first one is left to right. This one is going to be right to left. It's just the opposite direction. So here's our left to right version. Here's our right to left version. They will give you the exact same slope. Now, let's see this in a couple examples on the next page here. Find the slope of the line containing each pair of points. Now, what I'm going to do is, in order to determine which point is left and which is right, it's actually pretty simple. We look at the x value. Which one is a less x value? We would see it's the first one. So our first point will be x1 and y1, and our second point will be x2 and y2. So now when we go to our slope formula, it's what m is equal to y2, which is 4, minus y1, which is 7, all over, in this case we have x2, which is 6, minus 2, which is x1. So I get a slope of negative 3 over 4. Now, I want you to conceptually think about this, even without knowing what the graph directly is, having it off to the side. If I take 2 points like this, and I realize this one is more left than this one, which is more right, you'll see that the y values actually decrease. I was originally at a 7 for y's, and then I decreased down to a 4. So having a negative slope should make sense because my line looks like the following. All right, let's look at example B here. So if I look at these, my x values are -2 and 4. So I would say this point is the left point and this point is the right point, just based on the x values. So I'm going to call this x1 and y1, and I'm going to call this point x2, y2. When I put it in the slope, it's going to be m is equal to my y2, which is -3, minus y1, which is 5, all over my x2, which is 4, minus the -2 that was x1. When I calculate this, I get -8 over 4 minus 2. We know that the double negative creates a positive, which would be 6. And now I can reduce these both by 2 and get -4 over 3. So yet again, we get a negative slope, and we can conceptualize this by saying my left point was a value of 5 for y, and then my y2 was a -3, meaning the line decreases from left to right. All right, now for the next example, what we're going to do is we're actually going to do the opposite ordering. We're going to look at it from the right to left perspective and see if it changes our answer at all, which we know it won't. We're going to get the same ideal slope that we would have had. So if I look at the ordering here, I realize -7 comes before -2 on a number line, but I'm going to do it the opposite way. I'm going to call this point, or what I'm going to do is actually just keep consistent with the labels of x1 and y1, because this is the left point, and this one is x2 and y2. But now when I do my slope calculation, I'm going to change the order. It's going to be y1 minus y2 all over x1 minus x2. And we're going to see we get the same consistent slope value even doing it in this order. So m is equal to y1, which was equal to -9, minus y2, which is going to be equal to -9, divided by, in the denominator, we have x1 first, which is our -7, minus x2, which is -2. When I simplify this, I get -9 minus, which is a plus. That means I have 0 in the numerator over 7 minus 2, which becomes a positive. That's -5, a slope of 0. What type of line do we have here? It is a horizontal line. All right, and then finally with this example here, we see that both of my x values are actually the same. Now, you should immediately be thinking, okay, well, that's a little strange because which point's my left and which one's my right? Well, in this case, let's just pick whatever point as my left or right. So I'm going to say this one is my x1 and y1, and this is my x2, y2. We're going to see why those x values are the same. If I plug this into the slope formula, m is equal to, my y2 is 9 minus the -5, which is y1, over x2, which is 3, minus 3. This is going to give me 9 minus 5, which is a plus. This is 14, all over 3 minus 3, which is 0. And I know I can never divide by 0. As soon as I see this situation, that's not allowed. We know this is an undefined slope. So I'm going to put undefined below. And any graph with an undefined slope, what type of graph is it? It's a vertical line. So this is the graph we have in the case of an undefined slope. Now, just to prove it to yourself, what you could do with all 4 of these examples is you could say, what if I just instead take x1 and y1 and I put those points as the first point and vice versa, or I just swap the ordering in my calculations, similar to what we did down in example C, or mislabeled as example A, but we look at example C here, you realize we did y1 minus y2, x1 minus x2, instead of y2 minus y1 and x2 minus x1, and we would have got the exact same slope, flipping those values and doing it the other way. So don't be overly concerned with the labeling of left and right points. However, it's a really good habit to realize, okay, my left point is the one with the lesser of the x values, and my greater or my right point has the greater of the x values. Now, let's recall a couple details here. If the slope of a line is undefined, then it is a vertical line. in which the x-coordinate of the points are the same. Because in a vertical line, do you see how we don't displace left or right? We stay exactly where we are. So there's no left and right shift. It's a vertical line in which the x-coordinate doesn't change. The opposite case is if we have a slope of a line which is 0, and that means we have a horizontal line. In which the y-coordinate doesn't change. Because if we look at a horizontal line, we realize it doesn't move up or it doesn't move down. It's consistently at the same y-coordinate or the same level. It doesn't vertically displace at all. Now, what we want to do is before we go into example 2 that deals with collinearity, we want to define what it means to be collinear. To be collinear, it means that 3 or more points are said to be collinear if they lie on a single line. Meaning, if I draw a line as follows, so I draw a line in red, then to be collinear, points must exist on that same line. Now, just as a forward to where we may be going here, on any given line, it won't matter what points we select in order to calculate the slope. So I could technically do the slope here. I could do the slope between these 2 points. Whatever 2 points I go between, if they're collinear, the slope should be the same. So when we're dealing with that in the next couple examples here, realize collinear means they lie on a single line, but more than that, to be collinear, they have the same slope between any given points. So if we go to example 2, is the following set of points collinear? How we're going to determine this is we're going to say we need to connect D and E and see, okay, if I take the slope between D and E, what is it? And if I take the slope between E and F, what is it? And those should be the same. So right away, let's do the slope of D and E. The slope of D and E can be calculated by M is equal to the point that is further left is going to be this point here. It is further left than E. So it represents, in this case, our x1, y1. And E is our x2, y2. All right, so when we put it into our into the calculation, y2, which is 2, minus y1, which is 4, all over x2, which is 0, minus x1, which is negative 4. This is going to be equal to negative 2 over 4, which is equal to negative 1/2. And what we should see is if this is the point that's further left, we have a y value of 4 and it decreases down to 2. That means we have a downward sloping graph or a negative slope. Now let's do the same thing with E and F. If we want the slope of E and F, what we have to do here is we have to say, if I label these, well, this is my x1, y1, and this is my x2, y2. So when I put into the calculation, M is equal to y2 is negative 1 minus y1, which is 2, all over, we have 6, which is x2, minus 0, which is x1. 1 minus 2 is negative 3. 6 minus 0 is 6. This reduces down to negative 1/2. So therefore, because we're getting negative 1/2 for both, we know that all 3 points are on the same line or they're collinear points. Same slope. So we say, therefore, same slope. And therefore, collinear. All right, so this is going to be where you want to check your understanding. It's going to be really important figuring out what's the left point, what's the right point, and using slope formula, and then furthermore, extending it to see, are these points collinear? How do we determine that? They have to have the same slope. All right, now lesson 3B, which is problem solving. We're going to go through a couple problems that involve multi-step application here. So determine the missing value. For example 3, determine the missing value if the line segment joining these points has the indicated slope. So what they do is they give us the slope. Instead of us given 2 points, we have to calculate the slope. Now we have the slope and we have a missing value from one of those points. What is that missing value? It's the x value of our second point. So what we're going to do here is we're going to go, okay, if I know my slope, which is m, it's equal to negative 2/3, then in slope formula, it's y2 minus y1, which in this case we can go 6 minus 2 over, if our x2 is symbolized by x, we're going to go x minus that -1 in the denominator. Now, this is going to give us -2/3, which is equal to 6 minus 2 is 4, over x minus minus, we know that turns into a positive. This is x plus 1. Now what we're going to do is we're going to cross multiply these. I'm going to take this from the denominator and multiply it to the numerator. I'm going to take the 3 and multiply it upwards, getting rid of our denominators here. So we have -2 times x plus 1 is equal to 4 times the 3. We carry this over here. We get -2x minus 2 is equal to 12. I add the 2 across here, and thus I get -2x is equal to 14. And lastly, I divide by my -2 here, and I realize that the missing x coordinate for b is x being equal to -7. So that would be enough work to show that. All right, let's go on to example B. Similar concept, they say that the slope is equal to 2. So what we have is m is equal to 2. Now what we want to indicate that maybe we weren't so clear with on example A there, or part A, is we want to say this is going to be our x1, y1, and this is going to be our x2, y2. All right, now I plug this into my slope formula. Y2 is equal to 6 minus y1, which is equal to y, all over. Now x2 is 4 minus x1, which is 0. Therefore 2 is equal to 6 minus y over 4 minus 0. I multiply the 4 up to get it out of the denominator by both sides, thus giving me 8 is equal to 6 minus y. And if I carry this forward on the right here, I'm going to have, if I take the 6 away from both sides, -6, -6, this becomes 2 is equal to -y. And we know the coefficient when it's not written like that is always -1. And so we're going to go -1, -1, and thus we get a value of y being equal to -2. So the missing y value for our p coordinate is equal to -2. All right, determine the value of y if D, E, and F are collinear. So what we need to realize is we don't have a y coordinate for one of our points, but we do have an x and y for two of them. So what we're going to start by doing is our first step is going to be, let's determine the slope of these collinear lines, which we can use D and E for. Our slope is going to be m is equal to, I have to pick an x1, y1, and x2, y2. This is going to be my x1, y1, and this is going to be my x2, y2. So according to the slope, I'm going to have a y2 of 0 minus a y1, which is 4, over an x2, which is 6, minus an x1, which is -2. We know this turns into a positive with the double negative. Therefore, the slope is -4 over 8, which reduces down to -1/2. Now, we know the slope is -1/2. How can we figure out the y coordinate given that these are collinear? Well, now what we can do is say, okay, if I can now compare E and F and use that as a way to, and the slope as a way to solve for y, I can do that. Reason being is right above, we actually use this same format. Given 2 points with an unknown coordinate or a piece of the unknown coordinate and the slope, we could solve for it. So step 2, we're going to use E and F in our problem solving here. We're going to say our slope, which was -1/2, is equal to, and now we need to determine an x1, y1. So we're going to consider this our x1, y1, and this coordinate here is going to be our x2, y2. When we go down into the problem, our slope is equal to y2 is y minus y1, which is 0, over, now we have an x2, which is 8, minus an x1, which is 6 from the E point. When we simplify this, we get -1/2 is equal to y over 2. And if I multiply both sides by 2 to get that 2 out of the denominator, we're going to realize the 2's cancel here, the 2's cancel here, and thus, therefore, our y is equal to -1. So -1, when placed in for this missing y value in F, means that those 3 points would all be collinear. All right, and then last example here, example 5, the line through the point P, x2, and Q has the same slope as a line through A and B, which is those coordinates there, to determine the value of x. So what we need to realize is that we have 2 points in which we don't know one of the values of the coordinates. We don't know the x value, but they say it has the same slope as another line with specific points of A and B, where both A and B are known. All right, so what we're going to do is we're going to use A and B to determine their slope, and then use that same slope to help us get the missing x value for point P. So the slope of AB M is equal to, now we want to determine an x1, y1, and an x2, y2. So when I look at those 2 points, which one is a further left x value? It looks like it's going to be B, because it's the lesser of the x values. So I'm going to say this is our x1, y1, and A is our x2, y2. Okay, so y2 is equal to -3 minus the 5, which is y1, over 7 minus the 1. This gives us -8 over, if you look in the denominator, we have a double positive, or we have double negative, which becomes a positive. Therefore, our slope is equal to -1. And that slope is the same slope for P and Q, so we're going to use it. Now, to determine that missing variable, we go again, M, which is equal to -1, is going to be equal to, and now I want to assign both P and Q as x1, y1, and x2, y2. I'm going to classify this as x1, y1, and this is going to be x2, y2. So when we apply it, we say this is equal to, we have 6 minus 2 in the numerator, or the change in the y values, over -3 minus x in the denominator. Okay, we're going to simplify this. So we get -1 is equal to 4 over -3 minus x. I'm going to cross multiply this to the numerator, and here's how I do it. I'm going to multiply both sides by that 3 minus x. Multiply this side by the 3 minus x here. When I do that, it's going to cancel it from the right-hand side. And now I'm going to continue this just off to the right here. I have -3 minus x times a -1 is equal to 4. If I simplify this, I'm going to distribute my value from outside, and this is going to give me -1 times -3 is 3. -1 times -x is positive x is equal to 4. And lastly, I just move my 3 across, and I get an x value equal to 1. So an x value equal to 1 will make it so that P and Q have the same slope as A and B. So this is a bit of a two-parter. If you want to label the parts, we have 1 here, and we have part 2 here. All right, now it's check your understanding time. So whether it's the check your understanding for 3A or 3B, you need to make sure you're doing all these examples, because these are quite tricky, especially when you're dealing with part 1 and 2. You want to be really familiar with what the process is of, am I finding the slope? Am I finding a missing value in a point? What am I looking for?